Okay, well, good morning, everyone. Thanks for joining us here this morning. This is our first session. There will be a second one on what is engineering this afternoon. Those that are on the joining me here on the presentation this morning include Juan Guzman and Rachel McNutt from HDR Engineering. Roger Newberry from Partners Environmental, and myself. My name is Rich Eifelis, and I'm with CT Consultants. Both Roger and I have been involved with the ACE mentoring program since its inception here in the Cleveland chapter some 12 years ago, Roger, I believe.
Yeah.
Yeah, since its inception.
I know that.
Working each of us as mentors for different schools. I myself had now sit on the board of directors, as well as had chaired the education committee for the last 5 years, and moved on from that to some of the younger talent that is willing to accept the responsibilities to chair this. So, and together with a difficult time. So welcome again this morning to all of you. Hopefully you'll find this interesting. We'll try to make it interactive. It should only be about 3 to 4 hours. Okay, I know I can't see faces. That's supposed to get some kind of reaction if we were one-on-one, but seriously, we'll limit this to our 1 hour shoot for it no later than 11 a.m. So if you please, Rachel, next slide. So today we're going to focus on all the disciplines of engineering. The quotation that you see there at the bottom of this slide stems from really a conversation I had with maybe 10, 15 years ago with younger staff in our firm when they're trying to learn about what is it about engineering? Why are we doing what we're doing? There was a series out there called Project Y, and Project Y is led by this facilitator and asks various disciplines that are in careers why they do what they do. So for me, this quotation comes from something that I heard from my mentor from a lot of years ago. And I find the most meaningful reason why I'm a professional engineer is to protect, preserve, and enhance the quality of life. So with that in mind, what I think we're going to share with you today is what we, as all of us that are on this presentation here, are all engineers, primarily I would say in the civil engineering field. The civil engineering, when we get into that, you'll see it's rather broad, be it environmental, water, wastewater, transportation, site engineering, and things of that nature. So hopefully you'll learn something from our session here today of why that quote. If there's anything you take away from this morning, think about that message. Next slide, Rachel. So what is engineering? There's a short video here that Rachel's going to play for you, and it's something that my colleagues here, Rachel and Juan, had brought in from a presentation that they did a year ago, and I thought it was very useful for us this morning. So please, Rachel.
What is
excellent.
engineering?
Thank you.
Let's take a moment to think about your morning. The alarm on your phone goes off at 7:03. You drag yourself to the shower and blast yourself with perfectly warm water in an attempt to wake up. You smear your toothbrush with too much toothpaste and scrub yourself into a foamy mess of minty freshness. You're running late, so you skate downtown, weaving through the commuters, dart across the road, barely making the lights, and jump on the train just before the doors beep shut. There's a couple of stops to go, so you pull out your phone and play a few games of Angry Birds. Alarms, trains, traffic lights, video games, toothpaste, all these things were made possible by engineers. But what prompts an engineer to improve our world? Well, they solve problems. Problems are an engineer's inspiration, and maths and science are the creative tools they use to solve them. Problems like making your alarm go off at the right time, or making sure your toothpaste has just the right balance of chemicals to give you that perfect smile, or even making a game so addictive it's almost impossible to put down, if that really is a problem. Now let's head over to the airport and jump on an aeroplane. Aeroplanes. They're so easy to take for granted. But don't forget, you can fly! Before aeroplanes, flying was quite a bit more challenging. Every bit of your plane has been touched by engineers. A mechanical engineer designed the engine. A mechatronics engineer devised the controls. The fuel? Extracted by mining engineers and refined by chemical engineers. The navigation systems? Electrical and software engineers created those. Yep, a whole team of engineers. Now we've landed in Dubai, home of the Burj Khalifa. It's the world's tallest building at 829.8 metres high. It's also in one of the world's hottest environments, reaching up to 50 degrees in summer. One of the difficulties of building the Burj was trying to figure out how to set 45,000 cubic metres of reinforced concrete in such extreme weather. The solution? A clever method of pumping iced liquid concrete into the 55,000-tonne steel frame during the night. The result? A building that's vertically over 800 metres high, rather than horizontally all over the ground. Now let's jump into our time machine and go back to Saturday. Saturday, March 1932. The Sydney Harbour Bridge is about to open. The bridge is a marvel of civil engineering, and a pretty cool place to set off some fireworks. Since 1815, people had been talking about building a bridge to connect the two sides of the harbour. The problem was that the harbour was so incredibly wide. How could a bridge span such a width and support its own weight? The solution? The Romans! Well, actually it was an idea they came up with. The arched bridge works by transferring the weight into horizontal forces and bracing them at the ends of the arch. But what about the future? What problems will engineers solve next? Will we finally have affordable solar power? Or robots that can perform life-saving surgery? Or a building that's so tall your view is of outer space? Or how about finally engineering a working hoverboard? Seriously, we've waited long enough. So what is engineering? It's solving problems. It's taking crazy, out there ideas and seeing if they're actually possible. And when they are, the idea is shared with the world to make all our lives better. So, what problems do you want to solve?
Okay. Thanks, Rachel. I should have prefaced that video to indicate, first of all, 50 degrees is 50 degrees Celsius. It's in the metric system. And this was produced by, obviously, by Australia. And when I heard, I'm not good at the accent, but when she says Haba, I'm going, it's pretty cute. Just the way the accent. So I thought this was a really good video to overview, geez, what is engineering? So as we drill down here today, here's one of our first questions. The number and how many types of engineering degrees are there? As I mentioned at the outset, those on the call here today in our presentation are primarily in the civil engineering side, which has other very, very different specializations within it. But not really asking for a response in chat, but we'll go to the next slide just to indicate that how many types of engineering degrees are there. So there are more than 35. And it's even that number is probably low, and we say 35 plus. Quite frankly, with the advent of technology and what's occurring in the world today, didn't surprise me. There's just new facets or new specialties being brought up every day, all along engineering, and whether they pursue it in terms of a degree. But these are the main ones that we wanted to. We'll kind of overview here real quickly in the next few slides. Next slide, Rachel. Okay, this Juan is going to take over the next few slides. Juan.
Thanks, Rich. So first off, 50 degrees Celsius, I did the math real quick, is 122 degrees Fahrenheit, which is so hot. So when you get to those temperatures, you get a lot of problems with things melting, things not reacting the way you think they should. If you have a chocolate bar in your pocket, it melts because it's close to your body, and your body's at 90 something degrees, and once it gets past your clothes, it drops down. So 122 is a lot. So you get a lot of problems that come from that. So on this slide, you see many very, very large problems. And this is the fun stuff about engineering, is that you can ask questions however simple, and engineering is using math and science to figure out if those simple questions or simple responses can actually work. So I'm going to touch on each of these topics mentioned here, but speak a little bit more on climate change, since I'm interested in that. So space travel, The Martian came out. Interstellar is a phenomenal movie. That stuff is crazy. I don't know how you can send a ship to space. Like, you'd think we'd figure out car travel a little more effectively by now if we're in space, but there's a lot of cool thinking, and as the video mentioned, a lot of different disciplines of engineering that go into space travel. Cybersecurity, if anyone has a phone, which I'm guessing most of you do, Facebook, Instagram, Twitter, Reddit, all those things, being able to use those and not have your mom, for example, know what you're saying is an important part of reality. But then it goes a little deeper than that. Not having, for example, foreign governments or different companies or people that would want to hurt you know what you're saying and doing. That's really, really important. And cybersecurity is the use of math and science, or at least engineering, as it relates to engineering, is the use of math and science to try to help out with that problem. And I personally love the fact that not everyone knows every single thing that I say online. So that's a good thing. Soil erosion. As Rich mentioned, we're all have taken varying paths of civil engineering. And soil erosion is a huge, huge problem. One of the reasons when you see a river running through a city that you don't see dirt right next to the river is because of this. If you have a nice building that's right next to a river and you don't have the proper support between the river and the dirt, what's going to happen is the river is going to turn, and over time it's going to erode the soil or take some of the soil away, which is going to wear at the foundation of the building. So personally, I like it when buildings that I'm in don't fall. It makes me feel more safe. So soil erosion is a huge, huge part of that. New candy, Reese's Cups, phenomenal, the best thing ever. I'm happy that they exist. They make the world better. You can make cool new candy if you know the material properties and some manufacturing techniques, which engineering is very well geared to help with. And then renewable energy and climate change. These are really cool. Well, I mean, it's not cool. It's bad, but how to fix it? Like, most of you probably know that carbon dioxide is one of the main problems. So this is a great example of how simple questions can lead to incredible engineering responses, or at least could lead to them. So a simple response is, well, let's get the carbon dioxide out of the atmosphere. Okay, great. So one that leads to a different field of engineering, which highlights what Rich said, which is that there are tons of different disciplines, which is geoengineering. And there's a lot to talk about there, but if you're just, I should move on soon. Real quick on the geoengineering. The simple question of take the CO2 out of the atmosphere, you can do that. You can do that. It's just a matter of what else that impacts. So these questions that we ask ourselves as engineers and as everyday humans, engineering can provide a platform for thinking about them and seeing if they are possible. So there's some more problems to solve. There are a lot of problems to solve. Improving cars, mechanical engineering, self-driving cars, combining that with electrical and computer engineering. New makeup, that's chemical engineering, that's material science engineering. There's a lot there. Air traffic control, highway congestion. All these are problems that everyday people have and engineers try to solve, which I think is really cool. New medical devices. One of my friends is a biomedical engineer, which is the branch that typically deals with this. And he told me earlier this morning, actually, that there's a way to, if you lose your hand in an accident and get a new one, there's a way that when you press against something, you can actually feel that even though your hand is artificial. So that's the musculo-nervous system. He knows more about it than I do, but that's so cool to me. So all these kinds of problems in the world, or just things that can be made better, engineers help to make them better. So next slide, please. Thanks, Rachel. So here's a question for you guys. And it's a question that you can think on. If you have any answers that pop to mind immediately. Oh, I'm seeing that Elon Musk put a car in space. He's done a lot of things, which is very cool. So yeah, if you have any problems that you want to solve, please think on them over the course of this presentation. We're going to ask you guys again later at the end of the presentation. And then as you think of them, feel free to mention them in the chat. And also to respond to a student, you are supposed to put your school in the chat, and we already have your name from the account. So next slide, please. So here's a question which you can answer in the chat, and I recommend that you do. Do you think engineers are sitting at a desk all day? So I'll wait for some responses in the chat now. Any minute now. False.
Oh, sorry.
Okay, great.
Sorry.
Good. No. Oh, no, not you, Rachel.
Oh, okay.
Good. So false. No, absolutely right. You folks are absolutely right. We do not sit at desks all day. Engineering and problem solving is interacting with the real world. So, for example, I'm a water wastewater engineer. We have to go to plants to observe the conditions. In civil engineering, bridge inspections, water testing, site visits to see what the actual problems are, getting down with electrical panels, really seeing what the actual problems are. So sitting at a desk is an important component, but definitely not just what we do all day, fortunately.
All right, perfect. All right, so I'm going to start talking. I'm Rachel again. So I'm going to start going through the different examples of each kind of engineering, which we've already kind of talked on. But so chemical engineering, Candy, I know one of my friends in college, she was interning, and she actually was on the team that helped to make the Twizzlers with the, I guess, the gooey stuff inside. So I just thought that was so interesting. And I actually have a friend who works for a makeup company, so she gets to try out the makeup samples and as part of putting that all together, which I think is pretty awesome. And I never would have thought that was engineering until really learning about all the different types. Some other examples are glue, all chemical, and then fuel, petroleum, also chemical engineering. Biomedical engineering, which Juan was talking about earlier, a lot of prosthetics, helping to make, if like we lose a limb, helping to make sure we're still able to live comfortably, going into putting stuff inside our body to, like I said, make sure we live comfortably. Civil engineering, which the four of us all are, so different examples, roller coasters, designing. I'm not sure how many people have been to Cedar Point. One of my favorite things, roller coasters. There's a road on there, highway, bridges, big thing, trying to connect people over rivers and make travel better. A dam, try to help with water and making sure we're all able to live. And we are a little biased since we're all civil engineers, but it might be the oldest engineering in the world. It's to build and maintain basic infrastructure in which we live, including building everything from the pyramids in Egypt to modern transportation systems. So very broad, it's been around for a long time. Computer science engineering, doing website design. I know my little brother is actually a computer science engineer, and he's working for a company, and he's helping to do all the online and website updates, which beyond me, but he really likes it. Fortnite, a computer science engineer, helped to design that. There's some coding in the bottom right, so you could see kind of how that works in the background. Electrical engineering, I know you can need it for flights, you need it to be in your house, you need it for your jobs, lighting, transportation with the bridge example. Solar panels are starting to become more popular. That's all multiple different types of engineering. Rich, back at you.
Industrial engineering. So as we mentioned at the outset here, we're covering some of the broad areas of engineering. As we showed you at the outset, there's like over 35 in terms of degrees and disciplines. But these are interesting ones. Industrial in particular, while we as civil engineers don't relate directly to industrial, but what this is having to do with a lot of the abilities to manufacture our products, whether it be building products, automotive products, and what's occurring today in the field is a lot of automation and instrumentation that helps more efficiently produce the product from the raw material to the final product. And some of these then become and then how they're shipped and transported throughout the country, throughout the world, in terms of transportation of the product. So all these disciplines seem to interweave in some way. Next slide, Rachel. Mechanical. Different from an industrial, wherein we're looking at the ability, and especially in the automotive industry, in the airline industry, the ability to design and improve the performance of the vehicle, of the plane, as an example. These are just a couple examples, but mechanical is really anything in motion. I kind of brag about, or I should say brag, when I get questions as to why I chose civil engineering as opposed to something mechanical, my mind doesn't work with things that move. It's a simple answer. You probably don't relate to it yet, to all the students out there, but civil engineering is dealing more with foundations and structures, and yes, it does deal with hydraulics and flow, but when it comes to mechanical systems and they move, my mind didn't work that way, so I chose. Next slide. Oh, I forgot about that.
Quick little.
Thank you. Little demonstration on, again, these are all of these disciplines, and some of them, as you see, especially in biomedical and such, could be overwhelming. I know at your age, it was overwhelming, but with a good education, what you're doing now, and hopefully what you elect to pursue, if it is engineering, the accredited schools in this country and even locally are remarkable, and you'll learn so much. Next slide, Rachel. So we're gonna just talk about briefly what each of us do. Most of my career has been involved in the water wastewater industry, although I've held many hats across the disciplines in my career. At this point in my career in my firm, I'm primarily responsible for some business development and managing our corporation, managing the business. It's a learned trade, I would tell you, as an engineer, trained in engineering. I went on to get a graduate degree in engineering. Looking back, I might have opted maybe something for an MBA or something in business to get my mind a little bit more ready for what was to come, but I didn't know where it was to come. I didn't know where I would be. I didn't know I would be in a private consulting firm, which again, most of us we're consultants. We help our clients do this work. So most of my work in my firm is involved in figuring out what is the project, what does it amount, what does it take for us to deliver the project, and then manage the project. And at this point in my career, also I've been involved in a lot of the community and civic affairs. The reason I mentioned that here today is I kind of preach that to our staff at a very young when they come in. That involvement, whether you want to do it or not, there's a benefit and there's a value to the people around you, but there's a value to you that you may not see when you're in your 20s. You may not see it, but it comes, what goes around, it comes around. You start to build a network, if you will, and it helps you with your communication, your organization, skills that I think benefit you in your whatever career you choose. Next slide, I think, is Juan.
Mm-hmm.
Yeah.
Yeah. Thanks, Rich. I definitely agree. And this slide is a little bit more about the kind of work that I do. So this is a slide that I created last year. So the work that an engineer does day to day kind of changes with the projects they're involved in, especially on the civil and consulting side. So this project pictured here is the Coney Island Wastewater Treatment Plant in New York City. It's a plant that treats wastewater for about I think over 1 million people. So it's just enormous. Kind of my work on this was related to designing the pipe systems, making sure that the pipes could handle the pressures, making sure that the pumps were adequate to provide all the flow, make sure nothing was overflowing, and to ultimately put down a set of drawings that made sense for any contractor to pick up. So we were basically giving the instructions and all of our research, all of our thoughts on how to build this thing for somebody else to pick up. So to do that, I had to call manufacturers for pipes, for pumps, for other components. I had to do calculations for flow, hydraulics, and make sure that all the pipes were supported well so they wouldn't fall down. And then also coordinate with the other engineers in the project. So make sure that the pipe that we're designing wasn't going through a pillar or a heating duct or something like that. So there's a lot of coordination involved and communication as well. And now, as a wastewater engineer, the project I'm currently working on is a little bit higher level, where instead of designing pipes and doing calculations, I'm thinking for the city of Avon Lake nearby, how they'll be able to keep providing clean water to their customers and citizens 20 years down the line. So what kind of problems they're going to face in the future, how to solve them, and how they can go about preparing to solve them now. So that's where some of the problem-solving aspect continually comes in on different orders, both detail-oriented, like where should this pipe go, and also higher level, like how are we going to keep getting clean water to these people as new challenges arise?
All right, so I'm up next. I am a roadway engineer, so I have my undergraduate in civil, and then from there I branched off into going the transportation routes, and from there I am a roadway and a highway. So daily I'm designing and coordinating what the client wants to meet project needs, deadlines, working on that. Communicating with the clients, a lot of emails, cold calling somebody. I definitely have gotten over my fear of calling somebody. At the beginning, starting out right out of college, I was very nervous about how to explain things as being new, but everyone's very understanding, and now I have no issue calling someone I've never met before and just saying, hey, what's going on? What do you need? Or here's some answers to a question you might have. So that's what I do daily. So roadway, highway, so I design roads and highways. And some examples within this, right here is guardrail, which you will see by a road or sidewalk where then the ground goes to a really steep slope. So this prevents your car from going over and going into, say, a really steep slope. This is an impact attenuator. So this will take, so if you're driving fast and you veer off from your lane, this will help to take all the energy from your car hitting it. So then you don't hit this concrete barrier here, which will do much more damage to you and to the barrier. So really helping both parties. And then within roadway, I really enjoy maintenance of traffic, or MOT is the shorthand. And this is all, when construction is going on, all the orange cones that everybody hates because you get backups and everything. That's me. I'm sorry. I love it. It's a big puzzle. I love solving the puzzles, and that's just another way to how to go during construction, making sure you have enough width in your lanes while still be able to build the additional pavement or make the roads wider. I really enjoy that. Big puzzle again. Another aspect of roadway design is drainage. So when it rains and water hits the pavement, where's it going to go? It can't pond in the middle where you're going to drive over it because you're going to hydroplane, and that's dangerous. So I help design catch basins and ditches along the sides of the road to make sure everyone's safe. And a picture on the slide, this is a detention basin. So this helps to store water for treatment, and it also prevents flooding. So I'm sure you might see those on the side of the highway or in parks. So that is a civil engineering thing. Yeah, so that is what I do. All right, up next is Roger.
Oh, gonna wake me up now, huh? So Rachel and Rich and Juan have gone through some of the things that civil engineers do, various different types. I am a generalist civil engineer. I actually started out my career by drawing site plans for commercial buildings, stores, and shopping centers. But I've done a little bit of everything that we've talked about, and a few other things on the side. I just finished a project in East Liverpool, Ohio, trying to track down mercury waste in hospital drainage system, which was something a little bit different, a little bit out there. But again, something that the engineers can learn to do. I had a person tell me once upon a time that engineering was just a disciplined approach to problem solving. So you figure out what the problem is, or you identify a problem, and then you choose different pathways to try and resolve it. And if it doesn't work, you go back and start over again. But the discipline is the important part, tracking the solution through until it either fails or succeeds. But yeah, I've done highway work. I've done water and wastewater work. I've designed site plans, university hospitals, downtown campus. The Cleveland campus was designed. The new stuff that was done 10 years ago was my design, as well as Ahuja Medical Center, Hillcrest, a whole bunch of stuff around. Right now, I'm involved in a paving project, which is why my rollers are out there. It's not quite that big, but we've been working for 5 years to repave a single-family or a subdivision in Beechwood that is privately owned and maintained. The electrical stuff is interesting. What I know about electricity is that you pour a bunch of electrons in one end of a wire and they come out the other end. And the idea is to make sure that as many as you pour in, that many come out. I'm not sure how to me, you pour the electrons in, magic happens, and they come out the other end. But the electrical distribution systems and telecommunications and wireless, all of those infrastructure pieces are part of what the engineer designs. Next. So I decided to include a drawing because that's a lot of what engineers do in some way or form. We need to communicate the ideas that we get in our heads to the customers and to the contractors who are going to help build it. So we prepare drawings. This happens to be a site plan, conceptual site plan for a group of soccer fields in Bay Village. The issue here was that heavy black line you see wandering around the picture is a old landfill with some hazardous waste materials potentially in it that was capped many years ago, and the city now is paying the price to get that cleaned up correctly, or at least get it in compliance with the modern requirements. So that's drawings are a big part of what we do, whether it's drawings for a highway or drawings for a maintenance of traffic plan or drawings for a wastewater plant. Drawings is how we primarily communicate. The good news is now they're all done on computers, so you don't have to worry about whether anybody can read your handwriting, which in my case, yeah, in Juan's case, is a good thing. Okay. That's what I got. Next. Yep.
All right. Thank you, Roger. All right. So you just heard what all four of us do. So I really would like, just so you guys understand, all four of us have a civil engineering undergraduate degree. But within this one degree, there's many paths you can take. So like Juan and Richard went the water wastewater path, and that's where they went. I went the transportation route, and still within each of those branches, there's additional branches on top of that. And Roger was just all over. So, but it's nice to know that if you pick one and you're in school and you're in college, and like when I was in college, I really liked water and transportation. I wasn't sure which one I liked, and throughout the classes, it all still goes to my degree, and I ended up veering off towards transportation, and that's just, I really enjoyed the classes, and that seemed to be where my interest lied. So it might be daunting being in high school and trying to figure out what you want to do, all those, what do you want to be when you grow up, what college do you want to go to, all those very daunting questions that could be very stressful. Just knowing that it's still within each branch of engineering, no matter the degree, the 35 plus ones, there's still wiggle room. So once you get into it, there's still ways you can move. And even, so I'm roadway, say in 10 years, I'm like, oh, I've really been enjoying these traffic counts and traffic design. I can learn more traffic and then I'll be more well-rounded. So just because you choose a branch and a path doesn't mean you're going to be stuck there your entire time. And like Roger showed, he was able to dip in each one, which makes him very well-rounded, which is good because you want to be able, when you're designing something, not have tunnel vision. You want to be able to understand multiple things, which makes you a better designer and makes you a better engineer, which is what clients want, your companies want, and it's just a very good thing to have. So that's something I know I personally strive for, is to be well-rounded within civil engineering, and I would assume all my other colleagues would like to as well. So I just wanted to make sure you guys understand that you're not stuck with just one thing.
And Rachel touched on this before a little bit too. The one of the biggest things that especially the civil engineers do is communicate with the other disciplines that are involved either in the building project or whatever project it happens to be. We tend to be, as Rachel said, kind of generalists. We do a little bit of what everybody else does, but we are all tied together on a team, and making the communication between the engineering portion and civil engineering portion especially, and what else is going on in the world becomes critical.
Thank you, Roger. Yes, you're absolutely right.
I'm going to put it on no sound. Thank you.
All right. So we have another question for you students to try to understand. Does engineering require a graduate degree? So do you think this is true or false? So if you could please answer in the chat box, try to make sure we're all still there, not off in another room, that would be great.
So I've got a false from Nadej. I hope I pronounced that right.
All right, well, getting one response, well.
There's another one.
All right, well, false is the correct answer. You do not, is not required to have a graduate degree in going to graduate school. So going through that, so to become an engineer, if anyone is really loving our presentation, wants to go right into it, here is just an overall basis to kind of give you an idea. So college. Yes, you will want to go to a college that's accredited program. It's usually 4 to 5 years, depending on the type of engineering. And that's really the basis, the foundation for everybody. Grad school, it's not required, but some disciplines might prefer it. I know biomedical might prefer it, and I'm sure there's others. And like Rich was saying, you can go to grad school and maybe go the business route to help you later in your career as well. PhD, not required. Some prefer, like, really depends what kind of engineering you go into. Is there additional testing after school? Yes, there is. Not all different types of engineering require it. I know in the civil engineering, it is preferred that you get your professional engineering degree. So that's a PE, which you will see after people's names. So that's, you need, I think, 4 years experience. You need to take an 8-hour exam. And then you only need to take the exam once and pass. You don't need to take it again once you pass it. So that's something, and I'm sure other different types of disciplines have additional testing you can get and certification. So when we're in our career, we want to make sure as the technology changes and different things are happening in the world, you want to make sure you keep up with the time. So certifications are a great way to keep with it throughout all the different disciplines.
If I could interject here, Rachel.
Yes.
So just to add to what Rachel said, particularly in whatever discipline you may or may not be interested in and choose, what the professional license provides is credibility. So when we deal with, as you've seen, Juan's projects, Rachel's projects, Roger's project, we're dealing with the public. We're dealing with their health, their safety, and their welfare. So it's not just, all work needs to be overseen by a professional. So it provides that level of credibility to the public to ensure that the work is being done at a level commensurate with public safety. So it's kind of important in that regard, but it's not required. It depends on where your career paths lead. Thanks, Rachel. Just want to say that.
Yes, thank you. Yes. And last little bit is experience. For becoming an engineer, a lot of schools have internships or co-ops, which you go in and you're interning, you just get a taste of everything. So it's not required, but I'm sure there'll be plenty of opportunities to have internship or co-op experience. I know the college I went to required you did 3 semesters of interning, which after the first semester, some people switched engineering. Some people said that they knew this is what it was meant to be. So it's definitely good. It's definitely good to have. All right, Juan, back at you.
Okay, thank you, Rachel. We've had a lot of time to think. So given all that time, I'm hoping that some of you have come up with some problems that you want to solve. And again, this doesn't have to be like the problem you want to dedicate your entire life to, but just some problems that you think we can do better at as a society or personally or anything. So I'm going to be waiting for a couple answers in the chat.
While they're doing that, thanks, Juan. While they're doing that, here's the problem I want to solve. Dead man's curve. I'm not a transportation engineer, and those of you who obviously live in the greater Cleveland area, it's a familiar expression, albeit not so kind, on the Interbelt. And so the city, state, have worked on, I don't know, my lifetime, I believe. Roger, our lifetimes in trying to mitigate that problem at the interbelt, what we call the dead man's curve there along the shoreway. So there is a plan. It's a monumental, huge plan to divert the shoreway to another direction and if you will, straighten out the curve. So that's my problem I'd like to solve.
That's a great problem. And yeah, as you mentioned, that relates to public health and safety. There are a lot of accidents on that curve.
Right.
Wow, this is well formatted. In that time, Nadege, I apologize again, mentioned biodegradable plastic. That's excellent. Yeah, that's a field where it's developed a little bit, but not too much. So there are biodegradable plastics, but I think they're not very biodegradable. I think it still takes a very long time for them to degrade. So yeah, that's a perfect example. That bring in a lot of different kinds of engineering. Material science comes to mind.
Yep.
It's about this, I guess, throughout the entire presentation, but the take-home messages are that math and science are used to solve problems in engineering. And without communication, you can't really solve problems because you can't understand what the problem is. If you don't talk to people, you're not going to get their perspective on the problem. So your solution won't be as good typically. And engineering is everywhere. So thank you guys. This has been a lot of fun to present.
Yeah, thank you. Thank you very much to everyone. We want to close. We have activities to send, or do we want to overview that, or you want to go through your filtration video here?
Probably makes sense to overview the activities and then pass on.
Okay, good. Okay, we'll do that. Okay, so there's a couple problems that, thanks to Rachel and Juan, have put together, if you will, the take-home activity. One involves the traffic safety, as Rachel described her area of expertise and her area of where she's chosen, at least the beginning of her career in transportation. And so this exercise will be about counting cars. And it may sound simplistic, but there's a science to that. And it even involves what, coming from a neophyte in terms of traffic, I know our traffic engineers, they use these simulated computer programs called Synchro, I believe, where it actually simulates, based on counts, turning movements, queuing, if you will, how long you have cycles in terms of stop and go. So it's very involved, and if you love math and science, it's a great activity, a great field to choose. And then in water safety, there's one here about which we have explained, which actually will be distributed in more detail than this, but it's just to see what you can do to create clean water from dirty water. And it's a simplistic look at it, but as both Juan and my careers have chosen on the water wastewater side, it's all about the environment. So the water that penetrates the earth ends up in the ground, ends up in our water supply. The water supply is cleaned, it's brought in for consumption, and then that dirty water is sent back into the basic streams and groundwater. So it's an environmental cycle, and it's very important in our lives. And so that's why I relish, I really enjoy it, and I know Juan does as well. So this is a cool exercise that I believe we'll be sending out after this, right?
Correct.
Okay.
It's also just 5 minutes for the water part, or maybe 10, and is a lot of fun. So
A lot of fun, right.
Mine, you get to go outside and go to an intersection and count cars. So
you guys should just do both.
We want to thank you all again, but Juan has a short video that he put together himself to kind of close out our session here. And it has to do with water filtration, which we find very interesting.
That's what I'm doing.
I did the activity very quickly this morning. Juan Guzman with ACE Mentoring, and today we're going to try out a filtration activity for water. So this is a homemade activity. I prepared all of this in about 5 to 10 minutes, so you guys can try it at home in about as much time. This is just some water with dirt mixed in. I picked up the dirt from outside, and here on the right, you have a homemade filter. The layers are 1 old shirt, 2 paper towels, and 1 coffee filter. So we're going to see how this works to turn the dirty water, hopefully a little less dirty. So we're going to pour this water very carefully here. And it might take a bit of time for the water to seep all the way through the filter. That's another component of filters, is how long it takes them to filter the water and how much water they can put out, so the flow of the water. So we're going to pour about half of this total mixture in, so that way when this water finishes making its way down there, we can see the result. So another video will be incoming with the water pre-filter versus post-filter. Some of it's dripping down the side, but that's okay. All right, stay tuned.
Part 2.
I hate seeing myself on camera. All right, this is Juan Guzman reporting back in with some exciting news for Ace Mentoring. So the filter has done its magic, and there's less water than what we started with because a lot of it is still soaking up in the shirt. So we'd have to squeeze that to make it come out, but I think that's okay. I pushed back the shirt in the filter. You can still see the remains of the pour there, but yeah, so you can see that the filtered water, it's still a little bit cloudy. I wouldn't drink it, but you can see that it's a lot better than on the left, which is how it started. So yeah, this is a little bit of theory for water filtration. If you put water through filter materials, the materials can take out some of the dirt, which you can see actually here because the shirt is dirty, the paper towel is dirty, the coffee filter is dirty. And actually, let's see if we can, yeah. All that dirt that is on the filter materials is dirt that is no longer in the water. So try this at home. It's actually pretty cool. I think it's always cool to see when science actually works. So yeah, enjoy.
Excellent. Excellent, Juan. Thank you for doing that. I did this last night, but not with water and dirty water. I'm a fan of cold brew, so I got this concentrated Italian coffee, and I run the water through it. So I'm making coffee in the bottom, and then throw that in the fridge. So thanks, Juan. That was really good, really good ending. I think we're closed our session here this morning. Thank you very much for all of you that attended. Thanks all to Rachel and Juan and Roger for assistance in the presentation.